Hi and welcome to our 8th class. Today we continue our discussions on fundamentals of traffic flow and queuing theory. And I would like to start our class with going through an example that will help us understand better the effect of peaking and especially the effects of 15-minute peaking on traffic systems. So we talked in the previous lecture about ADT, annual daily traffic, and AADT, annual average daily traffic, and we said that those numbers show the average traffic that you have on a point on a highway facility over an entire day when it's average over the year or over a month. And we said that using those numbers for design is not appropriate because we have variations in traffic demand and the volume that we observed at a certain point on a highway facility, and those variations are really important because if you design a freeway or a highway based on the AADT, we are going to miss all of those variations. So what we did was that we said that we are going to find a peak hour within a day. So the hour that has the highest uh, hourly volume or hourly flow rate during the day. And now we want to see if we do that, is that going to be enough for design or we need to go into more details. So I want to start with highlighting this point that the variation of traffic within a given hour is also considerable. Okay, that's really important. And by this example, I try to show that to you. So what you see in this table is that from 5 to 5:15 p.m. I have a volume of 1,000 vehicles that want to go through a facility. And to make it a little bit easier, let's say um, this is what we have. So we have a freeway and we are looking at this point that I have here and we are counting the number of vehicles, or we are observing vehicles. So between 5 to 5:15 we are going to have 1,000 vehicles that want to go through this point. And between 5:15 to 5:30, 1,100, 5:30 to 5:45, 1,200, and that goes down to 900 vehicles. Okay, so that means that between 5 to 6 we are going to have the summation of all these numbers that are going to go through this part. But if I want to convert these volumes that I have for 15 minutes to hourly flow rates, what do I do? So I have 1,000 vehicles that want to go through that point within 15 minutes. How many want to go through that point during 1 hour? You just multiply this by 4 or you divide it by 0.25, right? So we're going to get something like 4,000 here. And for the next one, I have 1,100 that wants to go through this point within 15 minutes. So within an hour, if you convert that, you are going to have 4,400. If you convert the other one, we have 848 and then 36. Now the total number of vehicles that want to go through is 4,200, right? And I have 4,000, 4,400, 4,800, and 3,600 that if I convert those volumes to hourly rates want to go through the facility. Now, if I assume that the capacity that I have here is 4,200 vehicles per hour, what does that mean? It means that I can process 42 vehicles per hour at that point. Am I gonna have an issue between 5 to 5:15? I have 4,000 vehicles that want to go through. I can process 42. 100. This is less than that, so I'm okay, right? Let me just clean this up. So this is less than 4200. I'm okay. However, this number is more. 4800 is more. And if my capacity is 4200, you can see that I'm gonna have issue at these times. Let's take a look into these issues a little bit further in the next slide. So I'm assuming that the capacity per hour is 4200, or in other words, in 15 minutes, if you divide it by 4, it is 1050 vehicles. Okay, so that's the capacity that I have. All right, so in the first 15 minutes, I have 1000 vehicles that arrive, and I can process 1050 vehicles. Am I going to have a problem? No. Am I going to have a queue there? What is going to be the queue length? It's going to be 0. No vehicle is going to be staying there. Let's move on to 5:15 to 5:30. I have 1100 vehicles arriving, right? And I can process 1050 vehicles. Am I going to have any issue there? Yeah, I won't be able to process all of these vehicles. How many I won't be able to process? The difference of 1100 and 1050, right? My capacity is 1050. The number of vehicles that are arriving is 1100. So what is going to be the number of vehicles that I have in queue there? It's going to be 1100 minus 1050, right? So I'm going to have 50 vehicles in queue. What's going to happen in the next time step from 5:30 to 5:45? I have 1200 vehicles arriving. I can process 1050. How many am I going to have in the queue? Think about that. So I have 1200 vehicles coming. I can process 1050. That means that I have 150 vehicles that I won't be able to process. So is my queue length 150? No, because I had 50 vehicles from the prior time step that I could not process. So my queue length is going to be 150 plus 50, right? So I'm going to have 50. This is the queue that I could not process in the previous time step. And this is the new queue that I'm going to have. Okay, let's take a look at the last time step. In the last time step, 900 vehicles arrive. I can process 1050. So the queue is going to be 200 that I had. And I'm going to add 900 vehicles. And I can process 1050. So you could see that after the entire hour, there are 50 vehicles that are still in queue. But what is the total number of vehicles that arrived? The summation of all of these numbers that arrived is 4200. What is my overall capacity? Summation of all of these is also 4200. So while my per hour demand was equal to per hour capacity, you see that I could not process all vehicles there, and 50 vehicles remain in queue after 6 p.m. So would this be the case if I would have 1050 vehicles coming in each of these time steps? No. In that case, I could process all of those at the end of each time step and my queue was 0. But because we have variations in traffic and vehicles do not arrive in the same amounts within even each 15 minutes, you see this 50 vehicles queue that I have here. And for that reason, within the hour, we go and we select the peak 15 minutes of that hour, and we design the road based on that. So if you want to do that, what you do is that you go and you find the 15 minute that has the highest volume, okay, and you use that number to determine the peak hour factor. So if I divide my hourly volume, which is 4200, by my hourly flow rate, which is 4800, or 4 into 1200, I find 0.875, which we call it peak hour factor. So here is the formulation that we use for peak hour factor. It is your hourly volume divided by your maximum 15-minute flow rate, which is equal to 4 into your highest 15-minute traffic volume. And whenever you want to design something, you don't have these, right? You may have, a lot of times you don't, but you have your hourly volume. You also have your peak hour factor, and what you do is that our design volume is going to be equal to our hourly volume divided by peak hour factor. And as a result of that, as a result of this division, you are inflating your hourly volume so that you can design for this critical 15 minutes of that. So here is the equation that I just wrote it there. Maximum flow rate within the hour in vehicle per hour, or small v, is equal to your hourly volume divided by peak hour factor. And you see this equation over and over in this course. And also if you take a follow-up course such as traffic operations, you see that this equation shows up everywhere in that course. So now I would like to talk about headway, and also I would like to show you how you can start from headway and get to flow, or you can start from flow and get to headway. So let me read this sentence one time for you. I have talked about it previously, but let's read through it. The time between the passage of the front bumpers of successive vehicles. So there are a few keywords here. The first one is time. So headway in nature is time. Between the passage of front bumpers. This could be front bumpers, could be rear bumpers, but it's either front bumpers of both vehicles or a certain location that is the same for both vehicles. And then successive vehicles. We always talk about headway between two cars. So let's see what I mean. So let's assume that these triangles that I'm drawing, each of them is a car. Okay. The time that it takes for vehicle number 2 to get to the location that vehicle number 1 is, that is the headway between vehicle 1 and 2. And often we just call it headway 1. If you do the same thing for vehicle 2 and 3, you get the headway of headway between vehicle 2 and 3, and so on. Okay. So if you sum all of these headways, what does it tell you? The headway between the first vehicle and last vehicle. If you sum all of these, it's gonna exactly give you the entire time that you were doing that headway measurements, right? That's what I have here. T is the summation of all of those headways. So if you do this headway analysis between every two car that is gonna pass that certain point on a road, and you do that for, let's say, 2 hours, if you sum all of those headways, it's gonna be equal to 2 hours, okay? So T is the duration of time interval or study period that you have. Headway or HI is the headway, and N is the number of measured headways. So if you measure headway between N vehicles, N plus 1 vehicles, because this vehicle here is going to be vehicle N plus 1, right? If you measure the headway between N plus 1 vehicles, you're going to have N headways, and the summation of all those is going to give you the entire time that you are measuring the headway. So what am I going to do with that? Think about it. What was the definition of flow? Flow was N number of vehicles that pass through divided by T, right? So rather than T here, I'm gonna write summation of HIs from first to the last. And what that means is that I have N plus 1 vehicles, but N of those vehicles have passed my marker. So what is summation of HI divided by N? This is the average of headway, right? So here I have N divided by HI. So rather than average of headway, I have 1 divided by average of headway. So that's this equation that I have here. And you can see that from flow, I can go to headway, and from headway, I can go back to flow. So if someone tells me that the average headway between vehicles is, for example, 2 seconds, I can find what is the flow. And if someone tells me that the average flow or the flow is 1800 vehicles per hour, based on that, I can find the headway. I just need to be careful with the units of these, because if someone gives me headway in seconds, I'm gonna get flow in vehicle per seconds. And if someone gives me flow in vehicles per hour and I put it in this equation, so H bar is gonna be 1 divided by Q, right? So if I do that, I'm gonna get headway in hour, and I need to convert that to seconds, because most of the time when we talk about headway, we use seconds. When we talk about flow, we use vehicles per hour. So after flow, we want to talk about speed and travel time. So speed is something that we are all familiar with. It's the rate of motion, and its unit is distance per time. Travel time is the time that is going to take us to go from one point to the other point, or travel a section of a road. So if that time is shown by T and the distance is shown by D, speed is going to be the ratio of those. So far, so good, right? But something that starts to make things a little bit complicated is that in traffic we define two types of speed: space mean speed and time mean speed, and there is a big difference between the two. Conceptually, space mean speed is obtained when you are determining the speed over a section of the road. So what that means is that, let's say you know what time vehicles enter this section, and let's say this is the entry and this is the exit. So if you know that vehicle entered this section at a certain time, exited this section at a certain time, the difference between those two is going to be the travel time, right? And if you know the length of this section, L or D, so you can find the average travel time of all vehicles that entered and exited and divide L by that, and that gives you space mean speed. So what is key here is that we are doing that measurement over this length. How about time mean speed? So you have your road again, but only at this spot over an extended period of time we determine the speed of vehicles. So I don't know what their speed was here, here, here. I just have a radar gun and I measure their speed exactly here. So I measure speed 1, speed 2, speed n. So if you find the average of those that are measured at this one point, that gives you time mean speed. Let's move on and talk about these a little bit more. So here you see the official definition of time mean speed or spot mean speed. So this is the average speed of all vehicles that are passing a certain point on a road over a pre-specified time. So if you measure the speed of each vehicle as u, so you have u1, u2 up to un. If you add all of those and divide it by n, which is the total number of vehicles whose speed you measured, that is going to give you time mean speed. Okay? So at this point, you measure u1, u2, u3, un. We say the summation of all of those divided by n is going to be time mean speed. How about space mean speed? Space mean speed is the average speed of all vehicles that occupy a given section of a roadway over a specified time. Okay, again, we are looking at this section from this point to this point. So the distance is, for example, L. We know when or what time a vehicle enters, what time the vehicle exits. So you can either divide L by average travel time of vehicles, or you can say L, if you have n vehicles, divided by T1 plus T2 Tn. How many L's do I have here? I have n L's. So this is nL divided by T1 plus Tn, which is L divided by T bar. So here you see the equation again, much cleaner than what I did on the previous slide. So L is the length of that segment, T bar is the average travel time. And the average travel time, you can find it with this equation. Okay? So what here I try to show you is that how we can start from space mean speed and get to a different equation that we can find space mean speed based on that by looking at spot speeds. Okay, so let's take a look at this equation. So space mean speed L is L divided by average of t's. I have written average of t's like this. Summation of ti over n. So what I do here is that rather than having this equation here, I divide the numerator and denominator, both of them, by L. Okay, so if I do that, I'm gonna have 1 divided by 1 over n into summation of ti divided by L. Now I'm gonna do one more change here, and rather than writing ti over L, I'm gonna write 1 over L over ti. So this is equal to what I have here, right? Because I have switched L and ti here, and I have taken it from numerator to denominator. So that's the equation that I have here. Okay, so I'm gonna do one more step there, and L over ti, what is that? That is speed of each vehicle, right? So I'm gonna replace this with ui, and if you do so, you would see that I'm gonna have 1 over n into the summation of 1 over ui. So what I have here is the harmonic average of speed. So if I have the speed of each vehicle and I took the regular average of those, I'm gonna get time mean speed. And if instead of taking the regular average, I take the harmonic average, as you see here, I'm gonna get space mean speed. So that's the sentence that I have on this part of the slide for you. So I have an example here, an easy example that is not about space mean speed or time mean speed. It's about the MPG, mile per gallon for cars, but it's going to give you a good understanding of the difference between space mean speed and time mean speed. So let me read through it. You have two cars. They are both driven an equal distance, and one gets 20 mpg and the other one gets 50 mpg. What is the average mpg of these two cars? Okay, I want to ask you to pause the video here, solve it, and then unpause the video. If your answer is 35 mpg, I'm going to tell you from now that it is not correct. Okay, now that you went through this question, let's see how we can find the average mpg. So the mpg of the first car is 50, first car 20, second car 50. I add those and divide by 2, I get 35. No, that's not correct. Because here you need to think about the definition of mpg. The definition of mpg is how many miles you can drive per gallon, right? So if you want to find mpg, average mpg of these two cars, you need to find out that for 1 gallon of gas, how many miles we can go with the average of these two cars, right? So let's assume that we drive each of these 100 miles. Okay, I want to find out how many gallons I use for car number 1, how many gallons for car number 2. So for car number 1 or for car number 2, the one that has an MPG of 50, if I go 100 miles, I consume 2 gallons. For the other car, if I go 100 miles, I'm going to consume 5 gallons, right? So how much is my total consumption? 2 plus 5, or 7 miles, 7 gallons. It is the total that I have consumed. And with the 7 gallons, how much have I gone forward? 100 miles with the first car, 100 miles with the second car. So total miles is 200. So what is my MPG? It's 200 divided by 7, or 28.57. Space mean speed follows the exact same thing. You want to find the total distance, and total distance here is very similar to total miles, and you want to divide it by total time, which here is total gallons. Let's take a look at another example. So we have speed of 5 vehicles at the midpoint of a 0.5 mile section. Those are 44, 42, 51, 49, and 46 miles per hour. What is the space mean speed and time mean speed? So you can pause this video here. It's going to take you probably 2 to 3 minutes to find solutions, and then you can unpause. All right, so let's determine these two. If you want to find time mean speed, you can just find the average of these numbers, and that's the summation divided by 5. If you want to find space mean speed, you need to take the harmonic average. So for time mean speed, it's gonna be 44 plus 42 plus 51 plus 49 plus 46 divided by 5, or 46.4. For space mean speed, you're gonna use this equation, and it's gonna give you 46.17 miles per hour. So the other parameter that I want to talk about is traffic density. So this is the number of vehicles per unit distance. So if, for example, you have 500 vehicles, 50 vehicles that are in, let's say, half a mile of a freeway, your density is 100 vehicles per mile. So the number of vehicles divided by the length. That is going to give you the density. So density could be related also to spacing. So if you remember, we could relate flow to headway and vice versa. So we can relate density to spacing and spacing back to density, very similar to what we did for headway, because spacing is just the distance between front bumper of consecutive vehicles, right? So this is gonna be my S1, this is gonna be S2, S3, and S4. And if you are making measurement over a certain length of the roadway, the summation of these S's is going to give you that length, right? The summation of those headways were giving you the duration of total study time. The summation of these headways, this spacing, is going to give you the total length, right? So if you keep that in mind, and go back to the equation of density, then we see how we can relate them. So the summation of all S's is going to give you L, right? And you remember that density was N divided by L. So I'm going to replace L with this in the next slide. So rather than K equal to N divided by L, I'm going to divide N by summation of Si. And you know that summation of Si divided by N is S bar. So here I have the opposite of that. So I have N divided by summation of Si, which is going to be 1 over S bar, right? So you can see that if you have K, you can get S bar. If you have S bar, you can get K. Here is a great place to pause, and we will continue our discussions in our next class. Thank you.